Okay, so today what we're going to do is look into applying conditional probability concepts to calculate simple probability. And I'm actually going to break this into two parts. So this will be Unit 1A4 will be this stuff in table format. And Unit 1A5 will be word and tree diagram format. Now I know you don't know what any of that means, so we're just going to break that up here in a moment. Now the standards that we're going over here, if you care about it, you can just kind of look at this, pause the recording, you can look at it a little bit longer if you want. But it's all about conditional probability. Okay? So here it goes. Conditional probability is a type of dependent probability where you are finding the probability that an event B happens given that an event A has already happened. So this notation here, the probability of M with this little bar here and then N, it means it's the probability that, you should fill this in on your notes, probability that M occurs given that N occurred already, or given that M, the probability that M occurs given that N occurs before it. Okay, so this little symbol right here, the bar, whenever you see it, you will say the words given that. Another, a synonym for the phrase given that would be assuming that. It's an if-then sort of situation. So we're going to look first of all at the table types of problems and see how this goes down. We have this strange situation set up where maybe there's a room full of guitars, and there's acoustic guitars, there's electric guitars. Some of them are tan, some of them are black, and some of them are blue. Now, why don't we all just try to figure out right now, how many guitars are there total in this room? Can you do that for me? Let's do it by figuring out how many acoustic guitars are there. Total that up.
124.
So we get 124 total acoustic guitars. And how many electric guitars are there? Did I hear 114? Now, how many blue guitars? I want to go this way now and just kind of go across and total those up and see if that works out. See if our totals down here work out. So 78 and 42, how many tan guitars are there?
120.
Say again?
120.
120. How many black guitars?
90.
90. And how many blue guitars? 28. All right? So, what we want to do is find, in number one, what, by the way, what does this add up to be? 124 and 14, what does that add up to be? 238? Now, just to check and make sure, what do these colors add up to be? 120, 90, and 28. 238, so it matches, right? So we have 238 guitars here in this room. Now, in number one, we're going to calculate this out. And in my previous slide, I didn't give you the formula, so I want to give that formula to you now. This is the formula for finding the probability of A given B. The formula goes like this. It's the probability of A and B the probability of A and B occurring divided by the probability of just B occurring. Now, this is the formula. But in a table problem, you can actually make this a little bit easier. It's the number of guitars. Well, let me rephrase that. It's the number so I can figure out how to word this. Often I just write A and B over B. The number. Okay? I'll explain that in just a moment. Number one, they want us to figure out what's the probability of walking into this room blindfolded. We get spun around, we're blindfolded, and we pick a guitar. What is the probability that that guitar happens to be black, given that we have selected an acoustic guitar? Okay? So imagine for a moment that the room is in sections, like over here are the acoustic guitars, and over there are the electric guitars. And when I walk in blindfolded, let's suppose somehow I just walk straight to the acoustic section. All right? So if I'm in the acoustic section, I'm going to be selecting an acoustic guitar. And so now that I am selecting an acoustic guitar, what's the probability that I select a black guitar? That's how this works. So it's really, what's the probability of this happening, assuming that this other thing happened? All right? And it might seem a little complicated, but it's actually really easy. So here it is. This is equal to the probability of selecting a black and acoustic guitar divided by all the acoustic guitars.
Do we have to write the formula?
Just copy what I wrote right here. Okay? How many? Well, that's black, right? Let's see. Black. Oh man. How do I separate black from
BK.
blue? BK. How about that? All right. So what's the probability of selecting a black and acoustic guitar? Well, what I want from you is the number of black guitars that are also acoustic. Find the row that is black and find the column that is acoustic. So you've got this row here, and you've got this row here, or that column. Now, how many guitars are both black and acoustic?
34.
34. How many guitars are acoustic?
124.
124. And that, ladies and gentlemen, is the answer. Now, this number, this fraction, is what I'm going to be looking for on a test question. I want to see that fraction. Because that fraction right there, it doesn't hide anything. It tells me everything that I need to know. It tells me that you understand what you're doing here on these types of problems. Now, for the sake of doing it though, I think we should go ahead and get the decimal answer rounded to the nearest hundredth. So what is this rounded to the nearest hundredth? Let me hear from one of you. Francisco. 0.27, yes? Okay, there's your answer. So, let's jump down here because I think this is, let's see, that's black and acoustic. All right, let's go ahead and do number 2. And I'm going to erase my markings on this table. All right, so now we want to select a tan guitar given that we select an electric guitar. So what's the probability that that happens? This is equal to selecting, this is equal to the number of guitars that are both tan and electric. Divided by the number of electric guitars. And how many are there? How many are both tan and electric?
42.
42. And how many total electric guitars do we have?
114.
114. What's that as a decimal? I'm going to call in someone. Carter?
0.37.
0.37. Okay. You try number 3. Get a head start on me. So you're selecting the number of blue and electric guitars and dividing it by the number of electric guitars. So how many are both blue and electric? 16. And how many are just electric?
114.
114. Okay, is this clear?
Yeah.
Let's leave 4, 5, and 6 for your own practice.
Why are you so busy? That's your fault.
Let's do a couple of these for the heck of it. I want to look at these problems. Let's look at number 1 and number 2. And 7 and 8. So let me let you take a few moments and try those on your own. If you're watching the video, then you can pause it here and try these problems, and then you can see the answers in just a moment. Okay, so we've taken some time to look at these 4 questions, and our answers are as follows. Number 1, the number of people that their favorite leisure activity is sports, given that we are selecting from the number of females. In order to do this, we needed to know the totals really here. I mean, that's the best way. It's going to save us so much time if you go ahead and total these up. So what were the total number of females? Let me hear from Rachel.
Hold on, I messed up.
That's okay. Anybody, what's the number of females?
334.
334. Okay, and the number of males, anyone? 362. Do we agree with this?
Mm-hmm.
Okay. The number of people that favor sports,
106.
106.
Mm-hmm.
The number of people that favor hiking,
106.
106. Reading,
161.
161.
116.
116. Does that say phoning? Phoning, like being on your phone? I swear. Like sometimes, where do these questions come from? Shopping,
139.
139. Other,
68.
68. Okay, so now the number 1, the number of people that prefer sports and are female, how many is that? 39. And it's going to be divided by the number of females, which is 334. What is that written as a decimal? 0.12. Good. Number 2, selecting the number of, what's the probability of selecting a female, given that you select from people who prefer sports? This is, what's the total number of people that are both female and prefer sports? 39. And the number of people that prefer sports? 106. Okay, so notice number 1 and number 2, they both have, the numerator is 39, sports and female. However, the denominator is different. In number 1, the denominator is the number of females. In number 2, the denominator is the number of people that prefer sports. Okay, so what does that come out to be as a decimal? A point what? 38.
I got 37.
37.
Because it's
Point
0.367.
Okay, so it's 0.37. 0.37. Okay, that's good. Now, looking at number 7, what's the probability that we select a male, given that we select someone who prefers shopping? So, I'll just do this problem right here. The number of males who prefer to shop are 68. And the total number of people that prefer to shop is 139. And that gives me what as a decimal? Let me hear from Christian. 0.49. Okay, number 8. Now we're going to flip this. Assuming that we select someone that prefers shopping, what's the probability that we select a female? Okay, so what's the probability of selecting a female given that we select someone who prefers shopping? And the answer will be, what's the total number of females that prefer to shop? 71. And what's the total number of people that prefer to shop? 139. Now, what does that decimal come out to be? Let me hear from Shay. 0.51. Okay, I selected 1 and 2 as well as 7 and 8 for this reason. In number 1 and number 2, the numerators are the same, and in number 7 and 8, the denominators are the same in the fractions, right? So just there's all sorts of situations that are going to come up, but I want you to pay close attention to these types of situations and the meanings of them. Once again, number 7, what's the probability of selecting a male given that we select someone that prefers shopping? Versus number 8, the probability of selecting a female given that we select someone that prefers shopping. Okay, so that's good. And you've got some problems here that you can work on your own.